Hello everyone, I hope all of you are doing well and welcome back to my channel again in Mind and Maths. In this lecture, this is the third lecture, we will be doing some problem solving on number system. In earlier two videos, you have studied the theory parts and you have also solved some problems, and in this lecture, we will be solving only some problems. Okay, so let us start. Let us start with the first problem. The value of 1.999 dot 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 in the form p by q, where p and q are integers and q is not equal to 0, is. There are four options: 19 by 10, 1,999 by 1000, 2 and 1 by 9. We have to say which one is correct. So let us solve. Say x is equal to 1.999 dot dot dot. We can write it as x is equal to 1 plus 0.999 dot dot dot. This is considered as equation 1. Now say y is equal to 0.999 dot dot dot, or we are multiplying both sides with 10. So 10y is equal to 9.999 dot dot dot, or 10y is equal to 9 plus 0.999. 10y is equal to 9 plus y. This 0.999 we can write it as y we have considered initially. So taking this y this side, so 10y minus y is equal to 9. So what is then 9y is equal to 9, or y is equal to 1. That means 0.999 we are taking it as 1. Now putting the value of 0.999 dot 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 is equal to 1 in equation 1, we get what we get. This x is equal to 1 plus this 0.999 dot 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 is equal to 1. We are putting it here, is equal to 1, or x is equal to 2. So our answer is this C, 2. Okay. The next question is, if square root of 2 is equal to 1.4142, then square root of root 2 minus 1 by root 2 plus 1 is equal to option A 2.4142, option B 5.8282, option C 0.4142, and option D 0.1718. So let us solve this problem also. We know that root 2 is equal to 1.4142. Okay. And now square root of root 2 minus 1 by root 2 plus 1. So what we have to do now is, can you guess what we have to do? We have to make this portion as a rational number. This is irrational. We have to make the denominator rational. That is what we call rationalizing the denominator. Let us try. What we are going to do is, to rationalize this, we are going to multiply the numerator and the denominator with root 2 minus 1, and let us see what happens. Root 2 plus 1, root 2 minus 1. This root 2 minus 1, this root 2 minus 1, we are multiplying it on both numerator and in denominator. Okay. Now this is root 2 minus 1 square, and what is this? This is like a plus b into a minus b. That means root 2 square minus 1 square, right? We can write it as, and what is this? A minus b whole square, that is equal to a square minus 2 into a into b. Here root 2 is a and 1 is b, plus b square, and in the denominator it is root 2 square means 2 and 1 square means 1. Root 2 square means 2 minus 2 root 2 plus 1 by 1. So we can write it as 3 minus 2 root 2. But instead of doing it like that, what we can do is, this is also irrational. So if I put the value of 3 minus 2 into 1.4142, it will be difficult to solve. So instead of doing this, what we will be doing is, this is root 2 minus 1 square by, this is 2 minus 1, that is root 2 minus 1 square by 1, that is equal to root 2 minus 1, and we are putting the value of root 2 is equal to 1.4142 minus 1, that is equal to 0.4142. So we are getting the answer C. You have understood? Okay, let us go to the next problem. Here the question number 3 is, cube root of 2 into fourth root of 2 into 12th root of 32. You have to simplify it. Okay. Cube root of 2 into fourth root of 2 into 12th root of 32. Can we write it as 2 to the power 1 by 3 into 2 to the power 1 by 4 into 32 to the power 1 by 12? Yes, we can write it. Okay. Now we are again writing 2 to the power 1 by 3 into 2 to the power 1 by 4 into, can I write 32 as 2 to the power 5 whole to the power 1 by 12? 2 to the power 5 means 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. 2 to the power 5 means. Okay. And this is 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Okay. So we can write 32 as 2 to the power 5. That is what I have written here. Right. So again we are writing 2 to the power 1 by 3 into 2 to the power 1 by 4 into, we have learned the formula a to the power m whole to the power n is equal to a to the power m into n. In earlier classes, you please remember that we have discussed about this. So the same thing, this 2 to the power 5 whole to the power 12, this also we can write as 2 to the power 5 into 1 by 12, that is 2 to the power 5 by 12. We can write it, yes or no? We can write it. Okay, 2 to the power 5 by 12. So now we if we combine this, what we know, a to the power m into a to the power n is equal to a to the power m plus n, we know. So in similar way we can write 2 to the power 1 by 3 into 2 to the power 1 by 4 into 2 to the power 5 by 12 is equal to 2 to the power 1 by 3 plus 2 to the power plus 1 by 4 plus 5 by 12. So So this is equal to 2 to the power 4 is 7, 5 is 12 by 12, that is equal to 2 to the power 1 is equal to 2. So the answer is 2. I hope you have understood this one also. Very easy problem. Let's go to the another one. Now the question number 4. Fourth root of 81 to the power minus 2. Fourth root of 81 to the power minus 2. We can write it as 81 to the power minus 2 whole to the power 1 by 4. Okay. Again we are writing it as 81 to the power minus 2 by 4. Okay. And what is 81? 81 means 9 square. 9 square to the power minus 2 to the 9 square whole to the power minus 2 by 4. 9 to the power 2 into minus 2 by 4. So this is 2 2 2. 9 to the power minus 1 is equal to 1 by 9. This is the answer. And so I hope you have understood. And the next fifth question is, which of the following is equal to x? Among these four options, which one is equal to x? Option A is x to the power 12 by 7 minus x to the power 5 by 7. Option B is 12th root of x to the power 4 whole to the power 1 by 3. Option C is square root of x cube whole to the power 2 by 3. And option D is x to the power 12 by 7 into x to the power 7 by 12. So let us try with the option A, x to the power 12 by 7 minus x to the power 5 by 7. Can we do any operations on it? We cannot. Can we write it as x to the power 12 by 7 minus 5 by 7? No, this is not correct. If has it been like 12 x to the power 12 by 7 by x to the power 5 by 7, then we could have written it as x to the power 12 by 7 minus 5 by 7. This would have been correct, but this is not correct. Okay, so we cannot do any operations. So we have to keep it as it is, okay, option A. And now the option B, 12th root of x to the power 4 whole to the power 1 by 3. Let us see what we can do with it. X to the power 4 by 3, we can write it. This is 12th root of, okay. So now what we are writing, x to the power 4 by 3 whole to the power 12th root of means 1 by 12. We can write x to the power 4 by 3 whole to the power 1 by 12. So x to the power 4 by 3 into 1 by 12. Again, like this formula, x a to the power m to the power n, a to the power m whole to the power n, a to the power m n. We can write it similar thing. So this is like 4 3s are 12, x to the power 1 by 9. Okay. This is also not equal to x. This is also not equal to x. This is x to the power 1 by 9. So the option C is square root of x cube whole to the power 2 by 3. We can write it as x to the power 3 by 2 if we remove the square root whole to the power 2 by 3. Okay. So this is equal to, let me take this paper out. This is equal to x to the power 3 by 2 into 2 by 3. This becomes x to the power 1. This is equal to x. Okay. And let us check the option D also. So we have got this one is equal to x, and let's check the option D also whether the option D is correct also or not. X to the power 12 by 7 into x to the power 7 by 12. See, x to the power, I am writing sometime x to the power 7 by 12 like this, and sometime x to the power 7 by 12, like this. Both are same, okay, just to represent. So this is equal to x to the power, this is similar to uh, a to the power m into a to the power n is equal to a to the power m plus n. Okay, similarly x to the power 12 by 7 plus 7 by 12, x to the power 84 into 144 plus 49. So this will be x to the power 84 23 by 84. So this is x to the power 193 by 84. So what will be our answer? This one. See this. Okay. This looks a difficult problem, but it is not difficult. It is we are using what we have learned in earlier classes only. Okay, we are not using anything new. Okay, if you try to understand, these are all the things that we have learned from previous chapters, previous day video only. Okay. Now the sixth question is, state this one. State whether the following statement is true or false. What is the statement? There is a number x. There is a number x such that x square is irrational, but x to the power 4 is rational. Justify your answer by an example. What is the statement? Read it again. There is a number x such that x square is irrational, but x to the power 4 is rational. You have to tell whether the answer is true or false. Let us take the example. Say x is equal to square root of 5. X is irrational. No doubt x is irrational. What about x square? X square is equal to fourth root of 5 whole square is equal to square root of 5. Okay. What is this? This is irrational. Irrational number. But what about x to the power 4? X to the power 4 is nothing but x square whole square, that is root 5 square is equal to 5. Now what is this? This is a rational number. So through this example we can say that x is a number such that x is a number fourth root of 5 such that x square is irrational number. X square is equal to square root of 5 is an irrational number, but x to the power 4 is a rational number. So the following statement is true. Okay. Now the seventh problem. Let x be rational and y be irrational. X be rational and y be irrational. X is rational and y is irrational. Is xy necessarily be irrational? Justify your answer by an example. See, if you consider x is equal to rational, you take example rational number as 2 and y is equal to root 3. Then what is xy? Xy is equal to 2 root 3. This is irrational. But this is not always true. This is not always true for any value of x. If suppose if x is equal to 0, which is a rational number, and why you take any number, let us take same 3 is an irrational number. Then what is the value of xy? The product of xy is nothing but 0 into root 3 is equal to 0. And is this a rational number? Yes, this is a rational number. Product of xy becomes rational number. So let x be rational, y and y be irrational. Is xy necessarily be irrational? No, the answer is no, not always. It may be irrational or it may be rational. Okay, so let us jump into the question number 8. In question number 8, it is given that classify the following numbers as rational or irrational with justification. There are total 6 numbers are given. So let us first see. You have learned that what is called rational and irrational number. Rational is, first one we can say that if we can write it as p by q in the form of p by q, then it is rational, where p and q both are integers. Okay, and what is the second condition? After decimal, after the numbers, after decimal numbers are one is terminating, it should be terminating, or non-terminating, and recurring. Non-terminating, recurring. The opposite is irrational number. Okay, so let us see the first one. The first one is minus square root of 0.4. Let us break it. Minus square root of, we can write 0.4 as 4 by 10. Let us take it out. This 4, square root of 4 means 2 by square root of 10. Now if we consider it in the form of p by q, let me write it here. If we consider minus 2 by 10 in the form of p by q, then p is equal to minus 2 is an integer, but q is equal to square root of 10 is not an integer. So the number minus square root of 0.4 is not a rational number. It is an irrational number. Okay, you have understood it? What about the other one? Root 12 by root 75. We are writing it as root within 12 and 75. We can divide it like by 3. We get it as 4 by 25. This is equal to 2 by 5. And this is a rational number. Why? This 2 is an integer, 5 is also an integer. That's why this whole number is a rational number. Okay, and the next one is the third. The third one is 0.5918. This is clearly a rational number. Why? Because after decimal it is terminating. Okay, and what about the fourth one? 1 plus root 5 minus 4 plus root 5. Let us break it. 1 plus root 5 minus 4 minus root 5. This is equal to minus 3, which is a rational number. Easy? And the fifth one is 10.124124 dot dot dot. What is this? This is also a rational number. Why? Because this is 10.124124 then dot dot dot. What is that means? Then means again this is 124 this continues. That means 10.124 bar. This keep on continues. This is a rational number. Why? Because after decimal it is non-terminating and recurring or repeating. That is the justification. And the sixth one, 1.01001001 dot dot dot. What is this? This is a irrational number. If we expand it, how it follows? It follows 1.01001. The 10 increases, then another 10 increases, 0001. Then again, if we expand it, 4 numbers 01 dot dot dot. So it is purely an irrational number. Why? Because after decimal it is non-terminating and non-recurring. If you don't understand it, please listen the lectures again, the last two lectures, you will understand it. Okay. Now the question number 9. Find the value of a in the following. 6 by 3 root 2 minus 2 root 3 is equal to 3 root 2 minus a root 3. You have to find the value of a. How to find? So you have to make this left hand side and the right hand side equal. At least look like equal. Then we'll compare the one part with another part. I think you are not understanding, but we will compare one part with another part. We'll see how we are comparing. But for that, what we need to do, see in the right hand side, the rationalization of the denominator is already done. The denominator is already rational number. Okay. In the left hand side, the denominator is not rational. We have to rationalize it. Okay. So let us try to rationalize the denominator first. In the left hand side, we are writing 6 by 3 root 2 minus 2 root 3. So how to rationalize it? Very easy. On the both top and bottom, we will multiply with plus sign. 6 into 3 root 2 plus 2 root 3 by 3 root 2 minus 2 root 3 into 3 root 2 plus 2 root 3. Okay. So let us quickly do it. 6 into 3 root 2 plus 2 root 3. And what is this? Take it as a, consider it as a, and consider it as b. Consider it as a, consider it as b. So it is same as a plus b into a minus b is equal to a square minus b square, isn't it? So we are writing it as 3 root 2 whole square minus 2 root 3 whole square. So, and we are multiplying in the numerator with 6. 18, no, let us not multiply, we will multiply it later. 6 into 3 root 2 plus 2 root 3 by, let us see what it comes. This is 36. 3 3 is a 9. 9 into 2, sorry, it is 18. 18. Okay. And what is this? 2 root 3 square. 2 2 is a 4. 4 3 is a 12. Right? This comes out to be 6 into 3 root 2 plus 2 root 3 by 18 minus 12 is equal to 6. 6 6 gone. 3 root 2 plus 2 root 3. So if we write 6 by 3 root 2 minus 2 root 3 is equal to 3 root 2 minus a root 3. The same thing I am writing here. This thing I am writing here. Or what is the value of this thing? This thing we have got here. 3 root 2 plus 2 root 3 is equal to 3 root 2 minus a root 3. Now we will compare each part. This part is equal to this part. See, 3 root 2 is equal to 3 root 2. Now what remains? This part and this part. We'll write it as, so now we can write it as 3 root 2 plus 2 root 3 is equal to 3 root 2 plus minus a root 3. So this is equal to this. So 2 root 3 or 2 root 3 is equal to minus a root 3. So a is equal to minus 2. Easy problem. Okay. Now the question number 10. Simplify 5 within bracket 8 to the power 1 by 3 plus 27 to the power 1 by 3 whole cube whole to the power 1 by 4. So let us solve it. 5 8 to the power 1 by 3 plus 27 to the power 1 by 3 whole cube whole to the power 1 by 4. Okay. So can we write it as 5? This is equal 8 to the power 1 by 3 is equal to 2. 2 into 2 into 2 is equal to 8. Okay, so 2 to the power 2 cube is equal to 8. So 8 to the power 1 by 3 is equal to 2. Okay. Similarly, 27 to the power 1 by 3 is equal to 3. 3 into 3 into 3 is equal to 27. So that means 3 cube is equal to 27. That means 3 is equal to 27 to the power 1 by 3. This is 3 whole cube whole to the power 1 by 4. 5 into, this is 2 plus 3, 5. 5 cube whole to the power 1 by 4. And what is 5 cube? 5 5s are 25. 25 into 5 is a 125. We will not write it. We will write it as this 5. 5 means 5 to the power 1. 5 to the power 1 into 5 to the power 3. What is this? This will be is equal to 5 to the power 4 whole to the power 1 by 4. Why? 5 to the power 1 into 5 to the power 3 is equal to 5 to the power 1 plus 3 is equal to 5 to the power 4. Similar to a to the power m into a to the power n is equal to a to the power m plus n. Okay. So, and what is this? This will be 5 to the power 4 into 1 by 4. Okay. Well, how this comes? A to the power m to the power n is equal to a to the power m into n. The same thing, this becomes 5 to the power 1 is equal to 5. You understand? Okay. So the next question 11, this is easy question, and the another other type of question is this one. Find three rational numbers between -1 and -2, 0.1 and 0.11, and then 5 by 7 and 6 by 7, and then 1 by 4 and 1 by 5. Let us take the case 1, -1 and -2. Can we write -1 as -1 into 10 by 10? That is equal to -10 by 10, and -2 is equal to -2 into 10 by 10, that is equal to -20 by 10. Okay, so in between -10 by 10 and -20 by 20 by 10, you can find not only three numbers, 3 4 5 6 7 8 9 numbers you can find. So what are the numbers? You can write it as -11 by 10, -12 by 10, -13 by 10. Take these three numbers. Ho gaya, khatam. And then comes this one, the 2, 0.1 and 0.11. Okay, so can you write 0.1 is equal to 0.100, and 0.11 is equal to 0.110? So in between these two, what we can find is 0.101, 0.102, 0.103. So three rational numbers we have found. And then the question number 3, 5 by 7 and 6 by 7. Again, you multiply this 5 by 7, you can write it as 50 by 70, and 6 by 7 is equal to 60 by 70. So find the three numbers. Yeah, you have found three numbers, rational number, three rational numbers, and again here we are finding three rational numbers as 51 by 70, 52 by 70, 53 by 70. Again we have found three rational numbers. Okay, and the similarly the fourth one, 1 by 4 and 1 by 5. We are writing 1 by 4 as 10 by 40, 1 by 5 as 10 by 50, and some other numbers are 11 by 40, 12 by 40, 13 by 40. Three rational numbers we have found, right? This is a type of question, please note it. Now we will be doing we will be solving a problem on graphical basis, graphical manner. Don't get afraid of this, you have learned this also in earlier classes. The question is locate square root of 17 on number line. In earlier class you have learned it, like you have learned how to locate root 2 in number line. Like we have drawn a number line like this, 0 1 2 3. How we have done? Root 2, 0 1, and then from 1 we have done a perpendicular of 1 unit length, then we have joined this, and then this is root 2, and taking this as radius, we cut this number line and we got the value of root 2 here. Okay, similarly we are going to do this, we are going to solve this problem also. Let us try. Let me first draw a number line. So how we are going to use the logic? We have to find root 17. What is root 17? Root 17 we can write it as 16 plus 1. Can we not? We can write. So it is like what is root 16? Root 16 plus 1 means we can write 16 as 4 square plus 1 square. So here root 2 is equal to square root of 1 square plus 1 square. So we have taken here 1 unit and here another 1 unit. So what we are going to take here is will take one unit as 4 unit and another one unit as 1 unit. Let us see how it goes. This is 0, 1, 2, 3, 4, 5, 6, etc. Okay. So first we are going to mark the unit 4. From this unit 4, we are going to draw a perpendicular line first. How we are going to do a perpendicular line? You have learned in earlier classes. Here we are going to apply it. We are taking a compass. We are putting this pointed end on the point 4. Now taking this. Okay. So I put this point here and cut this circle here, arc here, and I'll put the point here and cut the circle. Okay. Then I put the point here again, the circle here. I'll put the point again here and cut the circle here. Like that way, we are getting a perpendicular line. Perpendicular to what? Perpendicular to this number line. This is number line. We are drawing a perpendicular line perpendicular to this number line. And now let's join it. Let's see whether it is really perpendicular or not. Yeah, it shows exactly 90 degree. Here you can see. Okay, so it is perpendicular line. Now we will take 1 unit. At this point it is 1 unit. Okay, so let us join it. Okay, so if we name it as A and this is B, then this AB is root 17, square root of 17. And how do we represent it in on number line? We have to take AB as radius and A as center. We have to draw an arc. AB as radius and A as center and drawing an arc. And let's see where it touches in number line. It touches somewhere here, very close to 4. Let us mark it as B dash. And let us see what it comes if we mark it. If we try to check, this is nearly it shows see, this in between 4 and 5 there are 10 divisions are there, so it comes nearly the first division, just out of that first division. So maybe 4.1 or in between 4.1 and 4.2 or maybe 4.11. this OB dash comes 4.11, that is equal to square root of 17. And you also check in your calculator what it shows, whether it is 4.11 or not. If it comes 4.11, that means we have done it correctly. Okay, right? You have understood it. Let me tell you again what we have done from the beginning. First, we have drawn a number line, plain number line. Then we have marked some points with taking 1 centimeter as one unit. This is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. So like that, up to 6, 7, 8, whatever we want, we have marked it. And now we have marked the point number 4, that is 4 centimeter. 4 centimeter, and from the point 4, marking 4, we have drawn a perpendicular line. I have shown how to draw the perpendicular line. After that, on the perpendicular line, we have marked 1 centimeter from point number 4 here, and that is called point B, the 1 centimeter. And now this AB is square root of 17, and taking the point A as center and AB as radius, we have drawn an arc and have checked where this arc has cut the number line, and where that point where the arc has cut the number line, we have marked it as B dash. And now this AB dash, OB dash, or this is A, point A, this is not O, this is 0. So this AB dash is equal to square root of 17. Okay, little bit lengthy but not difficult. Now the question number 13, this is also a graphical question. You also know this type of question, we have discussed it. Question number 13 is represent square root of 8.1 on number line. Earlier what we have learned, we have done, this is a natural number, we have presented like this, and now it is a rational number we are going to present in number line. Let us start. The same number line we are going to draw again. Let us mark it as point A, and from here we will take 8.1 centimeter. This is 8 and then comes 8.1, right? Then from that 8.1 we will take another 1 unit. From here to here it is 1 unit. Okay, see, this is 1 unit. Let us name it as point B and this as point C. AB is equal to 8.1 centimeter, BC is equal to 1 centimeter. Okay. Now considering AC as diameter, we are going to draw a semicircle. So first we need to find the radius or the center point. So the total diameter AC, how much it will be? 8.1 plus 1 is equal to 9.1. So the radius AC by 2 is equal to 9.1 by 2 is equal to 4.55 centimeter, right? So we have to mark it either from C or from A. We are trying to mark it from A itself. This is 4, this is 5, this is 4.5. and we have to mark 4.55. 4.5 in between 4.5 and 4.6, the 4.55 comes. It is difficult to accurately mark, but approximately we are marking. So this is the center point, center O. Okay, center O. Taking this center O, we are going to draw a semicircle. Chalo, we have drawn the semicircle. What is the next step? We are going to draw a line perpendicular to this number line. Again, we are writing it as number line. We are going to draw a line perpendicular to this number line from point B. So let us draw it. See, it is 90 degree. It shows. Now what we will do, we will mark the point where this perpendicular touches the semicircle. This perpendicular line from B, it touches the semicircle. It approximately touches here. Okay. Let us name it as P. Okay. This BP is square root of 8.1. This BP square root of 8.1. And how to represent it in number line? Again, taking the BP as radius, and B as center, we draw an arc and we'll check where it cuts on number line. And now what we have to do, we have to consider this B as 0. Then we have to draw some lines. This is 1, this is 1, this is 2, this is 3, this is 4, and see where it cuts. It cuts very nearer to 9. It is almost 2.5, 6, 7, 8, 9, 2.9. This point is P dash. So this BP dash, let us consider as P dash. BP dash is equal to 2.9 is equal to square root of 8.1. Please check whether I am right or wrong. So this is how we are going to draw or represent square root of 8.1 in number line. I hope you have understood it. Let me tell you again what we have done. First, we have drawn a line, what we have said as number line. We have taken this point as A, and we want the square root of 8.1. So we have taken 8.1 centimeter, and which is AB. AB is equal to 8.1 centimeter in scale. 8.1 centimeter we have first taken. Then from point B again we have taken another 1 centimeter. This BC is equal to 1 centimeter. So total AC is equal to 8.1 plus 1 centimeter, 9 centimeter. Okay. Consider 9.1 centimeter. Considering this AC, that is 9.1 centimeter as diameter, we have drawn a semicircle. What we have to do first, we have to find the center. What is center? Center is diameter by 2, that is 4.55 centimeters from any point, either from point A or from point C. We have marked the center as O and we have drawn this semicircle. Then from point B we have drawn a perpendicular, and we have seen where this perpendicular cut the semicircle. It has cut the semicircle at point, suppose at point P. So this BP length is nothing but square root of 8.1, and we have represented it in number line. How? By taking BP as radius and B as center, we have drawn as arc which has and then seen where it has cut in number line. It has suppose it has cut in number line in P dash point. So this BP is equal to the square root of 8.1, where we have to consider point B as 0, then point 1, point 2, point 3, point 4, like that we have considered. Then we have found this BP1 is equal to 2.9 centimeter. If we consider this B as 0, then 1, 2, 3, 4, like that it goes on. I hope you have understood this, and some more problems are remaining. Half of the problems we have solved today. Some more problems we have to solve. We will be solving in next video lectures. I hope you have understood today's problem solving class, and in next lecture we will do another problem solving. Thank you, and please like, share and subscribe my channel. Thank you.